In this video, we'll unlock the power of DAX in Power BI, the formula language that takes your reports from basic to brilliant. Whether you're looking to create custom calculations or transform your data into actionable insights, DAX is the key to transforming your data into actionable insights. Join me as we dive into the world of DAX and show you how to harness its full potential to supercharge your Power BI reports. Let's get started. So, before we begin, make sure to like, share and subscribe. Do not forget to hit the bell icon to stay updated on the latest tech content from Edureka's YouTube channel. Also check out Edureka's Microsoft Power BI certification training by PwC Academy, the link to which is given in the description box below. With that said, let's see the agenda for today's video. First, we will see the DAX use case. Then, why DAX is important. Moving on to, what is DAX function? Then, how is DAX used? Next, we will also learn the DAX function. Lastly, we will see the DAX hands-on as well. Now let's get into the video. Moving on to the DAX use case, assume Adidas is preparing for a worldwide product launch at the start of a new sales year. They have carefully planned their collection of clothing, accessories and shoes, laying the groundwork for a prosperous season. But as the months pass, difficulties start to show. I'm going to tell you about the issues now. The primary challenge in the Adidas sales data set is identifying the key factors influencing sales pattern, such as popular products, seasonal trends, and the impact of promotions or pricing changes. This insight enables precise sales forecasting, helping Adidas optimize inventory, production, and marketing strategies to effectively meet future demand. The key factors in the sales patterns are identifying factors influencing sales, such as popular products, seasonal trends, and the effect of promotion or pricing changes. First we have is the sales forecasting. Use insights to create accurate sales forecasts, helping Adidas anticipate and meet future demand. Next comes the inventory or production optimization. Leverage forecasted data to optimize inventory and production, ensuring sufficient stock levels without overproduction. Last is the marketing strategy enhancement. Align marketing efforts with sales insights to target high demand periods and also popular product categories, boosting overall sales effectiveness. Now we will see which method Adidas was using. Adidas and similar companies typically relied on traditional reporting and analysis methods, such as Excel and SQL, where basic sales data analysis often uses Excel for pivot tables, charts and summary metrics, and SQL for querying databases to extract specific sales data. Next we have is the ERP systems. Large companies often use enterprise resource planning systems, that is ERP, like SAP or Oracle to manage the report on sales data. These systems can handle complex business rules but are less flexible for custom, dynamic analysis compared to tools with DAX. The last we have is the static reports. Before Power BI, many companies use static reports generated monthly or quarterly. These reports could include aggregated sales figures, inventory levels, and profitability analysis but lacked interactivity. Custom scripts in R or Python. For more advanced data scientists, custom scripts in Python or R allow deeper analysis through statistical modeling and machine learning, though these lack the interactivity and self-service features of Power BI. Now let's see finding the right function. Adidas then determined that, based on a few crucial elements, DAX in Power BI was an appropriate tool for their analytical needs. Robust time intelligence. Power BI with DAX functions that allowed Adidas to analyze sales patterns, seasonality, and growth trends efficiently. Then we have the seamless Microsoft integration. Power BI integrates with Microsoft products like Excel, SQL Server, and Azure, making it easy for Adidas to manage data without extensive re-engineering. Then we have interactive reporting. Power BI's interactivity enabled Adidas to drill down into data by region, product, and season, allowing faster, more flexible insights than static reports. Then we have self-service customization. Power BI's DAX functions empower non-technical users at Adidas to create tailored reports without relying heavily on IT support. Last we have scalability and cloud support. Integrated with Azure, Power BI supports Adidas's global operations, efficiently handling large data sets and generating insights at scale. Now let's see the solution after using Power BI DAX. To solve the Adidas sales problem using Power BI DAX, first we have the sales growth calculation, using DAX functions to track year-to-date or quarter-to-date sales growth. Then we have is identify high-performance products. Create measures with calculate function and filter function to find the top products based on sales or profit margins. Then we have a seasonal trends. Use data add function to compare sales trends across different periods, that is months, quarters and years. Last we have a sales forecasting. Implement DAX time intelligence functions to forecast future sales based on the past performance. You now understand how Adidas use DAX. Now let's see why DAX is so important. DAX, that is called as Data Analysis Expressions, is a formula expression language that can be used with various business intelligence and visualization tools. DAX is also known as function language as the entire code is contained with a function. The DAX programming formula has two data types, numeric and other. Numeric values include integers, currencies and decimals, whereas other values include strings and binary objects. Moving on to what is a DAX function. A DAX function is a built-in function in DAX language that allows you to perform various operations on data in the tables of your data model. DAX functions also allows you to perform common data calculations on the data model. Some DAX functions have to be same names and functionality as Excel functions, but they have been modified to use DAX data types and work with tables and columns. As demonstrated in the following section, DAX includes additional functions for working with relational data and performing dynamic aggregation. DAX functions are essential when using DAX for data modeling and reporting. Now let's see how is DAX used. DAX, Data Analysis Expression, is a formula language used in Power BI and Excel to perform custom calculations that improve data analysis. It's primarily used to generate dynamic measures and row-level calculated columns, aiding aggregation and transformation. DAX also includes powerful time intelligence functions which allow for time-based analysis such as year-to-date or period comparisons. It enables users to filter and aggregate data based on a specific criteria, as well as work across multiple tables with relationships, thereby improving the data model. Now let's see the DAX functions. First we have is date and time function. These functions help you create calculations based on dates and times. Many of the functions in DAX are similar to the Excel date and time functions. However, DAX functions use a date-time data type and take values from the column as an argument. Next we have is a count function. The count function in DAX is used to count the number of non-blank rows in a specified column. It is one of the simplest aggregation functions and very useful for basic counting operations. The next function we have is the sum function. The sum function in DAX is used to calculate the total of a numeric column. It adds up all the values in a specified column. Moving on to the next function, that is max function. The max function in DAX is used to return the largest numeric value in a column or between two scalar expressions. The next function we have is the min function. The min function in DAX is used to return the smallest value in a column or between two scalar expressions. The last function we have is the filter function. The filter and value functions in DAX are some of the most complex and powerful, and differ greatly from Excel functions. The lookup function works by using tables and relationships like a database. The filtering function lets you manipulate data context to create dynamic calculations. Now let's start with the demo. For that, let's first get the data. So go to Get Data. So once you click on it, you can see the common data sources such as Excel workbook, Power BI semantic models, and so on. So here I'll be selecting text and CSV as my files are in text and CSV format. So here you can see on the screen that I have two files, that is Adidas dataset 1 and the other one is Adidas dataset 2. So if you want these datasets, please comment below in the comment section so I can provide you these datasets as well. So moving forward, let's click on one of the file and open it. Here you can see on the screen that my dataset is sourced. So let's click on load to load it. Now to check whether your file is loaded or no, towards the right hand side you can see data. Under that, Adidas dataset 1 is loaded here. Similarly, let's even source the other file as well. Click on load. So here again you can see Adidas dataset 2 is also loaded. Now if you want to view all the columns and its values of the dataset, go to table view on the left hand side. By clicking on it, you can see all the columns and its values that is given here for both the files as well. Now let's see how the count function works. For that, right click on the Adidas dataset 1. So here you can see the second option that is given as new column or new measure. Click on it. So here you can see the formula bar where you'll be applying the formula. It is given as measure in default. Let's change it. You can give your preferable name as well. I'll be giving count of orders. Now let's do the formula. Count. We use this count function to count the number of order IDs. So now we will select the order ID from the dataset 2 and click on commit. So once you click on commit, you can see under the Adidas dataset 1, count of orders column is created. So let's drag and drop it onto the panel. There you go. You can see the graph is created. But therefore I do not need a bar graph. I just need it in table. So I'll be picking table under visualizations. So now my count of orders is in the form of table. So as you can see that the text is not visible, let me make it a bit visible. So for that, let's go to format your visual. Under that, values. In values, you have font where you can change the size of the font. I'll be increasing it. So I have increased it to 15. And then column header to change the size of the header as well. Let me again increase it to 15. So here you can see that the text is now visible. So this is how the count function works under the DAX functions. Now to check the formula of count of orders, click on it. So here once you click, you can see the formula that is addressed here. Now let's learn another function for counting the rows in the dataset. For that, let's use new measure that is already on the panel to perform this operation. Now again, you can see that the default title is given as measure. Let's change it into, let's rename it to count of row and give the formula as. So we'll be using the function as count rows, which allows to count the number of rows in a table with the data set that is needed. So here we are going to use the function as count rows, which allows to count the number of rows in a table. So let's count the rows for the Adidas dataset 1 and close the parenthesis and click on commit. So here you can see count of rows has been displayed. Let's drag and drop it onto the panel and change this into a table. Similarly, as you can't see the text, you do not have to again go to visualizations and change it. You can just use Format Painter by selecting the previous table and click it to the latest table so that the same operation is applied. So here you can see that now our text is visible. Now let's use the function to find the duplicated values in the dataset. For that, again right click on Adidas dataset 1, new measures, and in the formula bar, just rename to your preferable name. I will be giving it as duplicate. Now let's use the function as distinct count with the data set, with the order ID in the data set. This allows to count the number of distinct values in a column. So now let's click on commit. And you can see the duplicated column has been created. So let's see how many duplicated values have been there. Let's make it into table. And let's use the Format Painter again to make the text visible. Here you go. You can see that there are 501 duplicate values in the dataset 2. This is how you use distinct count function to find the duplicated values in your dataset. Now we will use the sum function to find the total number of quantity in the dataset. For that, click on the new measure that is given on the panel and change the title to sum of order and use the function as sum. As we are going to sum up the quantity of the dataset, so let's select the quantity from the dataset 2 and click on commit. So here you can see that the column of sum of orders has been created. Let's drag and drop similarly onto the panel and change it into table. So now let me tell you how the sum of orders work. So for that, let's also select the name, drag and drop it onto the panel and sum of orders. Now, here you can see columns given under visualizations. So there are sum of order and names. So let's pull the name to the first. There you go. So you can see that a table consists of names and how many orders they have done. That is the quantity. Now let me align it in descending order. So now you can see that the values are in the descending order. So you can see the total number of quantities also given as 5615. Now let's use the format painter so that our table can be more visible. So this is how the sum function works. I hope you have understood how each order is taken by finding the number of quantity of the customer with their names. Now I will show you how to find the profit cost. For that, let me use the quick measure function. So let's go to the quick measure on the panel. And the use of the quick measure feature in DAX allows users to create commonly used calculations in Power BI without writing complex DAX code manually. It simplifies the creation of measures like averages, percentage, ranking, and much more. Now under quick measure, you can see select a calculation. So you can select a preferable calculation. Here I will be selecting the mathematical operation, under that subtraction. So when you click on subtraction, you can see the base value and the value to subtract. So now let's give the base value. For the base value, I will be dragging and dropping the total sales. And then for the value to subtract, let's drag and drop the units sold. So in the value of subtract, you can see the data options. So under data options in summarization, you have a lot of options like average, minimum, maximum, count, and so on. So you can give it according to your preferable values. So now let's click on add to add the quick measure. So here you can see the total sales minus the units sold column has been created. So now let's make it into table. So to know the formula, just click on total sales. So once you click on it, you can see the formula that is given. That is sum of Adidas dataset 1 with total sales minus sum of Adidas dataset 1 with units sold. So now as you can see, the title that is given is total sales minus units sold. I do not want this title, so I will just be giving it as profit cost. And just click on commit. So now you can see the total profit cost. So now let's use the format painter so that our text can be visible. Now we will see how max function works and find the maximum values in the total sales. For that, right click on the Adidas dataset 2 and click on new measure. Again, change the title. So I will be changing it into max. Now let's use the formula by max function to find the total number of sales from the dataset 1. Click on commit. So here you can see that the max column has been created. Let's drag and drop it onto the panel and change it into table. We will again use the format painter to make the text visible. So here you can see that we have the maximum values as 82500 in the dataset 1. So this is how you use the max function. So next, let's use the min function. Again, right click on Adidas dataset 2, go to new measures. Let's change the title to min and use the formula min by finding the total sales in the dataset 1 and click on commit. So here you can see the min column is also created. Let's again drag and drop it and change it into a table. Similarly, use the Format Painter. So now you can see that we have total min function is 16. So here you can see the minimum values we have in the total sales is 16. So this is how we use the min function. Now we will see how the filter function works. We use the filter function to find the number of sales. For that, let's click on New Measure on the panel. Change the title to Total Sales. For the total sales, we'll be using the formula by using filter function. By adding the total sales in the dataset 1, it should be greater and equal to 320. So now let's click on Commit. So here it's given a warning that already we have the name as total sales in another column. It is given that this title already exists. So let's change the title. Let's just give it as sales and commit. So here you can see that there is an error occurred. So the error in this formula is due to attempting to use a scalar value in a context where the table is expected or vice versa. The filter function always returns a table, not a scalar value. In our case, the formula is fine as far as the syntax goes, but the issue arises from how you might be trying to use the filter test variable later. Now to correct this error, let's add another function, that is countRow. The countRow takes the filter table produced by the filter function and counts the number of rows in that table. Essentially, it tells you how many rows meet the condition from total sales that is greater than equal to 320. Now just click on Commit. So here you can see that the sales column is again created. So now let's drag and drop it. Change it into table. Use the Format Painter to make the text visible. This is how the filter function works. So I hope you have understood all the functions that comes under the DAX functions. So if you're a beginner, it's important to know all these basic functions in DAX. DAX functions in Power BI are essential for creating dynamic calculations and interactive reports. They enable data filtering, aggregation, and advanced analysis, making it easier to build insights like KPIs and time-based comparisons. Mastering DAX unlocks Power BI's full potential, allowing users to handle complex data scenarios and create impactful dashboards efficiently. We have come to an end to this Power BI DAX tutorial video. If you enjoyed it, please be kind enough to like it. And you can comment on any doubts and queries. We will reply to them as soon as possible. Do look out for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.